Today, let's talk about the ubiquitous newly released UDR or UniFi Dream Router. If you have UDM, you may find they look very similar. So it's very sturdy in the front. You only have a small LCD. It's much smaller than the normal UniFi switch LCD, but in my opinion, it's much useful. Ubiquiti put all the important information for monitoring. Normally, you put this type of router on your desk. This type of small screen can save you a lot of time to log on to your computer and launch network controller. And in the back, that's the interesting parts. You have a WAN port here, and then you have 4 gigabits ports. 2 of them are PoE, not PoE plus, just normal PoE. And 2 of them are normal 1 gigabit RJ45. And here you have a micro SD card slot. I'm going to have another video just talk about this micro SD card slot and the internal built-in SSD. In this video, I'm only going to focus on the network performance. The initial setup of the network controller is pretty straightforward. I won't waste your time on the detailed step-by-step setup. I just want to show you several interesting observations. First thing, on the screen, you see the 3 different UniFi devices which run UniFi OS, UDR, UDM Pro, Cloud Key Gen 2 Plus. As you can see, the UDR can run 4 different type of applications, but see these 2 buttons, they are grayed out. This message, it tells you it can only run 2 applications simultaneously. It may not be a big deal for home user because normally you just need network controller and protect. But if you want to use all the applications, that's a apparent limitation for UDR. For UDM Pro, yes, it can run 4 different type of applications. Interestingly, it doesn't have the talk. And in the right side, for Cloud Key Gen 2 Plus, it can run 5 applications and it can run all of them at the same time. So apparently, because of the hardware limitations, Ubiquiti doesn't want you to run too many applications. Another interesting thing is about the legacy user interface. See the UDR? It doesn't have the option. It's the new product, and Ubiquiti simply doesn't want to develop the classic UI for it. For UDM Pro, you see the legacy interface switch, and for the Cloud Key, the same thing. You have a legacy interface checkbox. Let's talk about today's main topic, network performance testing for the UDR. This is the network diagram. I'm going to use this type of setup to test 5 different test cases. I have my home network and other switches, but I'm going to do all the testings in the lab environment. So the UDR is connected with my home network using the WAN port. In my home network, I have a Linux virtual machine. To this UDR, this Linux virtual machine is on the internet side. And in the LAN part, I have 2 virtual machines connected. So basically, using these 3 Linux virtual machines, I'm going to test the Ethernet-based performance. But remember, this UDR is a Wi-Fi 6 router. So another important performance testing is about the Wi-Fi speed. I'm going to use 2 Mac machines connect to the UDR using Wi-Fi 6. So let's briefly talk about the 5 different testings. First, of course, from LAN connect to WAN. Second, I'm going to enable IDS IPS. You may know even for the much more powerful UniFi routers such as UDM Pro or UXG Pro, once you enable the IDS or IPS, the performance will be dramatically impacted. So let's see how it works in this little brother, the smaller router. The third testing is about, okay, from LAN, from one of the Mac machines, I'm going to visit internet to visit this Linux virtual machine here. And the fourth testing is between these 2 Mac machines, Wi-Fi to Wi-Fi testing. And the very last one is purely between these 2 Linux machines on LAN part. Okay, so let's get started. During the testing, I'm going to use the same screen layout. In this window, I'm going to SSH into the router. For these two lower side windows, I'm going to use Linux or Mac machines, depending on which test I'm on. To start the first test, let me log on to the router using SSH. Let me quickly show you two screens. Right one showing the UniFi OS, and the left one is the network controller. There are two different places to set up SSH, but they are for different purpose. So in the right side, this is the one we want to use for today's testing because it's about SSH to the console OS, to the UDR router itself. But in the left side, network controller, if in the future you manage your UniFi switches using the network controller, this is the SSH settings for your UniFi switches. Now we are ready to SSH to UDR. And right after I hit enter, I need to wait for several seconds. It never happened in the past for me to log on to, let's say, UDM, UXG, or even the very old UXG Pro. For this new UDR, I need to wait for such a long time. That implies the CPU is not very good, already a bad sign. In this SSH, I'm only going to run one command, which is the top. So I use this one to show you the current router resources. Pay attention to several important numbers. The ID means idle. SI means software interruption. So basically, that's the way how the UniFi router deal with the network traffic. So now in the lower two windows, let me first show the IP address for the one part. It's .2.196. Let me first simply run one iPerf3 server. In the right side, from the LAN part, let's start the first testing. I'm going to run iPerf3, connect to the WAN part, the IP address we just got here. I specify a T parameter just to make it run for a very long time. Okay, it's just 500 megabits. Very slow. Let me queue it, increase the parallel connections. Let me run 10 parallel ones. Capital letter P. Okay, now it's better. So which means from your local network, if you try to access internet, your speed is close to 900 megabits. Queue it because I didn't specify the direction. By default, iPerf3 will send data. From your local network, you send data to internet. That means you are uploading data. Let's see whether for downloading it's the same speed. The way to specify the reverse direction is specify the capital letter R. You can only achieve about 600 megabits. And now let's check the SSH session. Idle part, it's not 100% busy. And if you check the SI, it's close to 40%. And of course, the top running process is the Ksoft IRQD, which is kernel software IRQ daemon, which is the one to process the network traffic. This time, let me run the testing in a different way. In the left side, for the Linux WAN machine, I'm going to run two iPerf3 server. Each one listens to different port. In the right side, I'm going to run two parallel clients. Each one connect to the server in the left side. For each one, I'm going to run for 60 seconds, and then in the end we can see the average throughput. For the first part, it's uploading. The second part, it has the capital letter R as parameter, so it's downloading, which means I'm testing the downloading and uploading at the same time. As you know, the Ethernet cable is working in duplex way. For each direction, the maximum speed is 1 gigabits, so theoretically it can run for two directions at the same time. Each direction at 1 gigabits, right? So let's see for this UDR's case, when we connect from LAN to WAN, whether it can achieve the same line speed. Let me start the left side, then start the right side. Okay, you can see the result already. For one direction, it's about 700 megabits, and the other direction is very miserable, less than 100 megabits. If you see the top session in the SSH, you can see the idle is 0, system is super busy. Top command even sometimes doesn't get refreshed because the system simply doesn't have enough resource to run anything else. That's why for one direction it's such a bad performance. It's not because line speed limitation, it's due to the systems, the router's hardware limitation. It simply cannot process such heavy traffic already. Okay, now we get the result. So in one direction it's 93, 96 megabits. And for the other direction, let me scroll up a little bit. Yes, it's close to 800 megabits. That means in real world, if you connect to internet, there's no way for both directions you get the same high speed, let's say 800 megabits. That's one thing, right? The other thing to consider is if you have very high speed internet, let's say you have 1 gigabit internet connection, so you cannot take full advantage of your internet. That's something to consider. Okay, so now we are done with the first test. For normal home user, I believe this speed is good enough. The next test, we are going to enable IDS or IPS. I have two UniFi controller windows open as comparison. So the left one is for UDR. If I go to firewall and security, enable the detect and block, which means it's IPS. If I select high, 11 thread categories enabled. In the right side, you can see for other UniFi routers, you can get 35 thread categories. Due to the weak hardware of the UDR, Ubiquiti simply doesn't want to tax the system too much. Let's enable it. Let's see what's the network performance. Apply changes. So here you see the exact same screen we left from the test number 1, right? For the test number 2, nothing else is changed. We are going to use the exact same environment, exact same command. So this will be an easy test to execute. In the left side, the two servers are still running. In the right side, let me run the exact same command again. Let's see what's the performance this time. Okay, so for one direction, less than 100 megabits. The other side, less than 800, not dramatically impacted. So basically before enable IDS and IPS, we have almost the same performance, right? Yeah, that's impressive. So let's check the top session. As expected, 0 idle, 82% is for SI. And if you check the running processes, you may notice there's a new one, which is for Suricata. So that's the one for IDS and IPS. Check what's the end result. For one direction, it's 700 megabits. For the other direction, it's 90 megabits. A little bit slower than the first testing, not too slow. Move on to the third test case. Only in the second test we want to enable IDS or IPS because we are done with the second one. Now let me turn it off so that it won't be a factor in our future testing. Before kicking off the Wi-Fi related testing, let's check the Wi-Fi connection first. This is the UniFi controller under client devices screen. I'm going to use the Mac Mini as the Wi-Fi machine to start the testing. In the right side, you can see the current status for this device. First thing to note is the MIMO configuration. It's only 2x2. This UDR router supports 4x4. Unfortunately, I only have 2x2 devices, then that means I cannot test the full potentials of the UDR, but at least I can test for normal devices what's the Wi-Fi performance. If you check the signal, it's very strong, and the RX rate and the TX rate is listed here, so that's the maximum speed we can expect. RX and TX rate are not perfect because I choose the automatic configuration and the system use the 40 channel width. Later in the force testing, I'm going to have some detailed explanation about the RF situation. So here, bear with me. Let's use the less optimal speed because you will see from Wi-Fi LAN to WAN, it cannot saturate this speed. We are ready to run the third test, which is from LAN to WAN via Wi-Fi. I already log on to the Mac machine number 2, which is from the LAN side. This one is the one we have been using for the Linux WAN machine. And similarly, let's start with one direction testing. Let me run iPerf3 first. In the Mac machine, let's start the upload testing first. Okay. 450 something. From the top window, you can see the system still has some capacity to run something else. It's not 100% busy yet. Then let me run the download. For some reason, it's slower than the upload. So by the way, Wi-Fi testing has too many factors to impact the results. So my testing is just for your information. Okay, so for download, it's less than 400 in my case. Now I already prepared the commands into Windows. In the server side, I'm running 2 parallel iPerf3 server. And in the client side, similarly, one for upload, one for download. Each of them runs for 60 seconds. And then in the end, we will take the average value. Run. Okay. So one direction is less than 20 megabits. The other is 400 something. And if you check the SSH for the UDR, you can see it's not busy at all. The bottleneck is not the CPU of the UDR. I will leave it run. In the end, let's see what's the average throughput. Okay, so now let's take the average. For one side is 400 megabits. For the other side is 20 something. This part is a little bit disappointing. Move on to the fourth test. In this test, we are going to use 2 Mac machines. They both connected to the UDR using Wi-Fi 6. This is the UniFi controller for this UDR device. In the right side, let me show you the setting and the radios. Ignore the 2.4 GHz radio. For 5 GHz, yes, I chose the 80 channel width and I manually chose 40. This is the RF environment. I already finished a scan, and for 5 GHz, as you can see, because I chose the 80 MHz channels. This the one I chose, 40 channel. I did try this never used channels, but they had even worse performance. So that's why I ended up with this one, because this one is already the best channel I can use. I did try to let the UDR to automatically choose channels, and it chose the same one, the 40 MHz channel. This is the UDR setting itself, right? Now let's go to the clients. Mac machines connected here already. They are both using Wi-Fi 6, using 5 GHz, and the experience keeps changing. Sometimes they are 100%, sometimes it's a 90%, and Ubiquiti never explain how this number is calculated. I guess it's based on the signal noise levels. And if I chose, let's say, the Mac Studio, here you can see it's 2x2 MIMO, and the RX rate and TX rate, they are both the perfect one. They are already the highest for these channels. I just show you what we see from the router side, from UDR side, right? Let's double check from the client perspective. Okay, here I show you side by side the two desktops from the two Macs. I just display the detailed Wi-Fi information. Let's read what we have here. So the channel is 40, signal level very good because I put them very close to the router just to achieve best performance. And the noise level, if you subtract these two numbers, for this Mac it's 60 something, for this Mac is 68. Not perfect, but good enough. Then for TX rate, it's 1.2 G. So everything looks good. I believe in your home network, it's very difficult to get better situation than this one. So then let's see how the network performance looks like. In the left side, I already run the iPerf 3 server in this Mac machine. And in the right side window, I'm going to initiate the client iPerf 3. First, let's test the upload. Less than 200 megabits, right? So it's already a little bit disappointing. Yes, both are using Wi-Fi. They both use the same wireless channel. Of course, you cannot expect the 1.2 gigabits speed, but about 150 megabits speed is a little bit disappointing. Then let me try the download. After 10 seconds was the average speed, 120 something megabits. So now let's test both download and upload running at the same time. Of course, this time I expect the average speed will be half. Because we are using two Mac machines, we have the advantage. Under Debian Linux, when you run iPerf 3, even the latest version, it doesn't support the bi-direction parameter, but in Mac, yes, it's supported. So that's why in the left side for the server, I only need one iPerf 3 server, and in the right side, I can start the two directions testing at the same time. This is the command I'm going to run. I specify the -- by dir parameter. Let me run it. Okay. As you can see, it has different labels, TX and RX. Let's wait. Okay, now it's showing the average after 10 seconds. That's a little bit disappointing performance. If you see I have anything wrong in my settings or how I can improve it, if you have any idea, please let me know in the comments. The last testing is supposed to be the easiest one, because as a modern router or switch, just to have the 2 gigabits ports to have the full speed switching, it shouldn't be a big deal. But let's see whether that's the case. So I have two Linux virtual machine running, number 1 and number 2. In the number 1, let me first get IP address. Then let me run two iPerf 3 servers. In the right side, let's first just test one direction. Let's start with upload. 900 something as expected. From the top session, you can see the system is not busy at all. So far so good. Let me run the reverse direction, the downloading, the same good results. Now let's start the bi-direction testing. In the left side, I run the two iPerf 3 servers. In the right side, similarly, two commands in the same line, and each one against a different port. One for upload, one for download. For each direction, it's slower than if I just run single direction testing. Interesting. So the router is pretty busy now. See, the idle is 0 and it's super busy running these two kernel software IRQ daemon processes, and the software IRQ, the SI, is more than half of the CPU utilization. Let me modify the command a little bit, then rerun it. Let me remove the parallel 10 parameter. Let's only run one connection for each direction. Okay, so the speed, of course, in the same situation, but let's see what's the server CPU utilization. Yeah, it's not 100% occupied. Yeah, it's a surprise. Even for the simple LAN to LAN speed testing, it cannot saturate the line speed. Let me summarize the 5 testings we just did. The market for this router is for normal home users. They may have several PoE powered cameras. Just this router may be already enough for the Wi-Fi requirements. There's no real need for super fast local network switching. Even the LAN to WAN speed cannot exceed 1 gigabits. Maybe it's not big deal for most home users. All the testing results which are not very satisfying in today's testings, I believe most home users don't really need them. It is still a good router for its market, especially if you consider its price. Okay, thanks for watching.